Hi, welcome to the video on balancing propane, C3H8. So when balancing a combustion reaction, there are three strategies that you want to keep in mind. The first one, which you'll see in this video, is to balance the oxygens last. So if you are given a chemical reaction and you know it's a combustion, remember you know it's a combustion because you'll have oxygen as a reactant. And for us, we're focusing on combustion of organic molecules, so you'll have a molecule with carbon in it, and you'll have oxygen as a reactant. And then on the product side, if it's a complete combustion, you're going to have CO2, carbon dioxide, and water. All right, so I look at this and I say, oh, got O2 and an organic molecule as a reactant, and CO2 and H2O on the product side. I know it's a combustion reaction. I'm going to balance my oxygens last. All right, so before I go into showing you that part, let's do what we normally do when we balance chemical reactions. We start by creating a tally of all the types of atoms or elements that we have on both sides of the arrow, because in order for it to be balanced, we want the same number of each type of atom on both sides of the arrow. So we have carbon, hydrogen, and oxygen. Those are the atoms I see, right? And I have 3 carbons. I have 8 hydrogens, and I have 2 oxygens. Do the same thing on the product side. And I like to keep the list of elements in order in the same order on both sides, just makes it easier for me to match it and see that they're balancing or not. You don't have to, so I just recopied CHO, but maybe you would write this as COH in the order that you see them written, of your choice. Okay, so we have 1 carbon, we have 2 hydrogens, and we have 2 plus 1, so that's a total of 3 oxygens on the product side. Alrighty, so now we're going to start balancing, and again we're going to balance the oxygen last. At the end of this video, I will tell you why we do that, but perhaps you'll see it as we go as well. Okay, so I'm going to start, since I'm balancing the oxygen last, I'm not going to start by balancing oxygens, of course. I can balance the carbon or hydrogen first. And I usually just balance carbon first because that's the first one that I often write. So I have 3 carbons on the reactant side, 1 on the product side. So I'm asking myself, well, what coefficient can I put in front of CO2 to get there to be 3 carbons? And that, of course, would be 3. I need 3 CO2 molecules in order to get 3 carbon atoms on the product side. All right, so that changes my number of carbons. But since CO2 is a compound, it's going to change the number of other elements as well, and that other element being oxygen, of course. So what I'm going to do is I'm going to calculate how many oxygens I now have on the product side. This is super important. Some students, what they do is they go, oh, I'm just going to add, added a 3 over here, I'm going to add 3 here. That's not what you're doing. You're thinking about mathematically what a coefficient means. A coefficient is multiplying. And so this coefficient is multiplying with that subscript. But then you have to add the number of oxygens that you have from the water, okay? So these are different operations that we're doing here. So the best thing to do, which I recommend, instead of just using your fast brain and saying I added 3 here, I'm going to add 3 here, is to recalculate it. So I recalculate my oxygens each time. So let's recalculate how many oxygens we have on the product side. 3 times 2, which is 6, plus 1 is 7. Now, if you just added 3, you would think you have 6 there, but you don't. So make sure you take your time to, again, recalculate 3 times 2, which is 6, plus the 1, which is 7. Okay, great. We did our carbons. Now we're going to balance our hydrogens, because, again, we're balancing the oxygen last. Okay, I have 8 hydrogens on this side and only 2 on the product side. So I'm asking myself, what coefficient can I put in front of H2O? Since, of course, this is the side that has the least amount of hydrogens. That will give me 8 hydrogens on both sides, and that will be a 4. So I go ahead and put a 4 here. 4 times 2 gives me 8 hydrogens, of course, right? So that's looking good. Now, once again, I'm going to recalculate my oxygens. I'm not going to just say plus 4, there's 11. No, I'm going to recalculate it. Okay, so let's go ahead and recalculate it. 3 times 2, which is 6, plus the 4, because it's 4 times 1. So 6 plus 4 gives me a total of 10 oxygens. All right? Recalculate those each time. Okay, cool. Last step is to balance my oxygens. So now I'm looking at my oxygens, and I have 2 on the reactant side and 10 on the product side. So I'm asking myself, what coefficient can I put in front of O2, right? Multiply O2 by, so I can get 10 on both sides. And that, of course, would be a 5, because 5 times 2 will give you 10. Okay? So that is my completely balanced equation. There's an invisible 1 in front of propane. I have a coefficient of 5 in front of O2, coefficient of 3 in front of CO2, and a coefficient of 4 in front of H2O. And I can double check to make sure everything is balanced at the same number of atoms on both sides. So if you want to know why we balance the oxygen last, this rule actually doesn't just apply to combustion reaction, but any reaction where you have an element that is found in more than one either reactant or more than one product, you want to balance that element last, okay? So if you look at oxygen is found in CO2 and H2O on the product side. It's found in 2 separate things. And so that's why we balance it last. Whereas if you look at the carbons and the hydrogens, like carbon and hydrogen are only found in one molecule on the reactant side. On the product side, carbon is only found in CO2 and hydrogen is only found in H2O. So why do we have to balance oxygens or any element that's found in 2 or more molecules last? Well, that's because whenever you change the amount of one, you change the amount of other, and you kind of keep going back and forth. Now, you don't have to balance it last. You could balance it first or second, but if you do that, it's just going to take you a little bit longer. That's the only reason why we use that strategy to balance the oxygens last. Okay, I hope you found this video helpful. Have a quality day.